In this video, we'll talk about the amortization formula and the implications for installment loans. So first thing I wanted to mention is the amortization formula in the slides in the packet looks a little different from the book. I just tried to make it seem a little simpler. It really is the same, and it's the same as if you were to look it up online or Google it or whatever. But I don't know. I just over the years I've noted this approach has seemed to be a little bit easier for understanding. Anyways, um, basically what the amortization formula does is it will calculate what monthly payment we need to make in order to pay off a loan on time. So let's say we're borrowing $500,000 from the bank for a house, and we are getting a 30-year mortgage. Let's say at 5% or whatever, kind of like the original example I posited a little while ago. Um, like if I was to put a particular payment on every month, how much do I need to pay every month to pay it off? And also this needs to take into account the interest that's accruing, because if I just, one obvious thing I could think to do is take that $500,000 and divide it by the number of payments, because over the course that like as I said, it was over the course of 30 years, but also in 30 years there's going to be 12 months of the year. So if I'm making a payment every month, I can figure out, well, there are 360 months in 30 years. So if I kind of divide it by 360 months, what that would imply is that, okay, that would break down into about 360 payments of $1,400. And that would add up to exactly the principal. But that's ignoring interest entirely. So this basic logic does not factor in interest, whereas the amortization formula does factor in the interest that's accruing every month by month on a compounding nature. And actually, the real detail of the amortization formula, why it is what it is, kind of like with there's some series and some series math that's going on here. But another class I teach this a little bit more rigorously, but there's quite a bit of math that again is something that we're not going to get into in this class that goes into solving the amortization formula, and it is quite interesting. But basically, in terms of our class, you can just use the formula. I'm not really going to get into the why, but it's a formula which solves the counteracting nature of a loan. And I just want to talk about what does amortization mean. But basically, as a loan over time, like imagine that $500,000 growing over time. As it's growing, we're also paying it off. So we can kind of imagine that, okay, this account is growing a certain amount of interest, but we're also subtracting money in the term of our monthly payment. So you can kind of imagine it as a fight, a struggle between interest growth and amount you're paying. And over time, you're actually going to be paying more than the interest that's accruing. Well, you always want to be paying more than the interest, but like over time, interest will get smaller and smaller because as you're paying it off, the balance of the loan will shrink. And so, like, while it over, the nature of exponential growth will still happen, it will actually grow slower and slower because the balance is getting less and less. And sorry, I know I'm not doing a fantastic job of explaining this, but essentially it takes into account the entirety of the loan, and it's kind of a remarkably simple formula at the end of the day. Well, it's really not that simple. It you know it's we're doing a pretty complicated thing as we do this. And so let's do an example. But basically, in the amortization formula, M stands for the monthly payment that I will need to make to pay it off. P is still the principal as before. And notice that we also have this M, little m, and T, capital T as well. Where M stands for the monthly interest rate, which, by the way, I think I forgot to mention this. In this amortization formula, this only will work for a monthly loan, a loan that we're paying off monthly, which is pretty much how they all go. So we're assuming it's compounded monthly, but I wanted to make to warn you guys here, notice that the question says that it's compounded monthly, but that doesn't mean we use the compounded monthly formula because whenever we're trying to calculate monthly payments of loans, we don't want to use the compound interest formula. That will not be right. That will solve a future value. Will have nothing to do with the monthly payment. So to solve a necessary monthly payment, we're just using this different formula. That's what the amortization formula is all about, is finding a monthly payment, and we're assuming it's compounded monthly. So if it were compounded differently, it would change the formula a little bit, but we're not gonna worry about that. But anyways, M is the monthly interest rate, or it's the periodic interest rate. Basically, it's your APR divided by 12, and you could imagine that as N is 12. And the number of installments is just N times T, 12 times T. Again, basically there's 12 months in the year, so the total number of payments is what that capital T is. It's very similar where M is like R over N in the previous compound interest formula, and capital T is like little n times little t. And sort of to try to say what I mean here, the structure of 1 plus r over n to the nt, basically we're changing this r over n to m, and we're changing this little nt to capital T. And that just simplifies the structure a little bit in the formula. So looking at this, it would be even like, and if you go into your book and try to and look at it, that's how it looks. There's like tons more stuff going on, but it just kind of less. I think this is a little simpler. Anyways, let's do an example. Let's say you have a student loan balance of $50,000 and it's growing at an interest rate of 7.2%. So this is a fairly realistic example. Say you have, you borrowed money from Sally Mae or whoever to go to Point Loma, which is quite expensive, and we want to know how much, how to pay it back. And another thing about loans is you can change the time frame of your loan. Typically, you can pay it back over 5 years or 10 years or 20 years, or it will depend. But another just basic principle to remember is that the faster you pay it off, the less interest you're going to be paying, because the longer and longer you let it sit, the longer it has for interest to accrue. And this is something that a lot of people get misled about, is they see a 10-year plan and it seems like it's better than the 5-year plan because the payments are less. But really the payments are less, but you're paying over 10 years instead of 5 years. So really it seems better, but it's typically not. And another general rule of loans, which is in the tips, is you can pay it off early, and you want to pay it off as early as you can. You don't just have to make the minimum payment on a loan. You can pay more, and I strongly suggest that you do. Because just like with credit cards, if you are if you're leaving your balance there unpaid, it's going to be generating interest at whatever the rate is. Typically, home loans are not as bad as credit cards, but 7% or 5% is still fairly high in the perspective of interest rates. And for some, I understand why student loans are often have interest rates like 7%, but I think it's a little bit criminal to have students have to pay such high interest rates. It's a risky investment. So the reason that things have the interest rates they do, there's a very good reason for it usually. And while it sucks, it's just part of life, and it's an investment that is not really that uncommon. Anyways, let's do some math. Okay, so let's start with the amortization formula. So the monthly payment is equal to the principal times little m 1 plus m to the capital T over 1 plus m to the capital T minus 1, end of parentheses, or end of bracket. And like before, if you just take the principal and you multiply into this big thing, you'll get the monthly payment. And there's a lot of math that goes into why this makes sense. It actually has to do with geometric series. But anyways, let's look at what we have. But also what I recommend is figuring out, well, what is M and what is T? We know that the principal is the starting value, which is how much I borrowed, which is 50,000. But the rest we need to know. So little m, the monthly interest rate, is going to be R over 12, because basically we're just going to take our APR and divide it by 12 to get what it will be in a month. And so let's toss that into our calculator. 0.072 divided by 12, which is 0.06. I'm sorry, 0.006. Be very careful with your decimals here, because notice that this would be a 0.6% rate. If I used 0.06, that would be 6%. That's 10 times faster. So obviously, keep track of your decimals. Be careful. I almost messed that one up. But basically what this is saying is that every month it's going to grow by 0.6%, which doesn't seem like much, but it's every month, which is fairly rapid. And that's going to be the base of my expression. So I'm going to have 0.006 here, 1.006 in there, 1.006 in there. And then the last thing I know is what is t. T is equal to 12 times the time frame, which is in years. So since this is since I assumed I was on the 20-year plan, that would be 12 times 220, 12 times 20, which would be 240 installments, which is just the number of periods. Or basically, you're just because there's 12 months per year over 20 years. So basically, if I'm paying off this amount every month for 20 years, this is how many payments I'm going to be making, 240. And that's going to be the exponent that's on each of those percentages. -1, end of story. And also, if you're going to type this all into your calculator at once, there's a couple things to be very careful about for your calculators. And this is something that I want you guys to practice this on your own, because if you enter it in wrong, you're going to get horribly wrong answers. And I want to sort of warn you about these things. But first of all, make sure that you're using a parentheses around the top and bottom of your fraction here, because if you type it into a calculator without parentheses in the correct location, it's not going to necessarily divide by this whole thing that you want it to. So you really want to make sure, technically you don't really need the brackets or the parentheses on top, but the parentheses on the bottom is very critical for the fraction. And actually, the TI-84 has a fraction command where you don't need to worry about all this, but this is a very common mistake I've seen a lot. Another thing that you want to be very careful about is the monthly interest rate. You do not want to round it. Or if you do, you want to use as many digits as you possibly can. Because in this case, when I found the monthly interest rate, it was round. I didn't have to round it. But let's say we were taking let's say we were taking 7% and dividing by 12. That interest rate would be 0.583%. And if you round that to say 0.005 or 0.0058, it's going to be off by a little bit or a lot, depending on by how much you round it. And really, since if I'm looking at this, if I round that number off, sorry, I have one too many zeros there, I just noticed. Let me fix that. Let me get back to my original point. Is that rounding will compound, because if I'm rounding this number and plugging it in there, and then I'm raising it to 240 power, the more and more you multiply by a decimal, the more it will change. And if it's off by a little bit, that rounding will compound and it will get worse and worse and worse. So summary, do not round your monthly interest rate. Use at least 4 or 5 significant figures. So really what I'd recommend doing is using like at least 58333 or something. Or another way you could do it is just type it in as 1 plus 0.07 divided by 12. Like you could actually just leave the fraction in there as I did before. But anyways, at the end of the day, those are my recommendations. But now let's go ahead and type it in and figure out what our monthly payment will need to be. So start with 50,000, multiply by 0.006 times by 1.006 to the 240. That's on top. And then I'm dividing by the denominator, which is 1.006. Notice I'm not quite using as many parentheses as I wrote, but it takes a little bit of practice in using this correctly. But the parentheses on the bottom are the most critical to make sure that you have. But assuming I do that all correctly, I should come up with a monthly payment amount that makes sense and that seems reasonable. But again, it's all contextual based on the amount that I started with. and so on. And actually, something about monthly payments is usually they're rounded up, which I actually rounded it to the nearest cent here, but more typically we're going to round them up to the always, regardless of rounding, just because if you round it down, you're actually going to be short a couple cents over the course of 20 years. You're going to be get a little bit shorter and a little bit shorter. It really doesn't make a difference, so I don't care. But I'm just going to round it up, even though conventionally speaking we would round down. Anyways, um, we could figure out how much our monthly payment, and then we now know that we would need to, when I'm paying off this loan, we're going to be charged about $400 per month on this loan. So also, if you're working on your budget project and you're wondering how much my student loan payment's going to be, you could use the amortization formula to approximate it. And just use your own plan. And technically, you don't need to change your plan. You can make your own plan by saying, okay, I want to pay it off in 5 years. What will I need to pay? And in this case, $400 doesn't seem very much, but over the course of 20 years, that's a long time, and that's a lot of payments. So the next part, the second part of example number 15 asks, over the life of the loan, how much will you have paid, and how much interest will you have paid? And that's kind of now that we know how much we're paying on a month-by-month basis, we want to then see what is the larger scale picture here. So basically, now this is going to be my monthly payment, and the assumption is that if I pay this off every month for 20 years, I will pay the loan off. But basically, I could figure out how much I'm going to be paying in total by taking the monthly payment and multiplying by the number of installments. So like if I'm looking at this, M just stands for the monthly payment amount, and T stood for how many payments I was making to begin with. So if I multiply those two things together, I don't know what's happening. I'm clicking things. I have no idea what I just did on my thing, but I think I fixed it. But basically, okay, my monthly payment was $393.68, and then the number of installments we had was 240 in that 20-year loan. And if I multiply those together, 393.68 times 240, that would leave me with $94,483.20, which is basically how much I'm going to be paying in total for that loan if I do follow the minimum monthly payments. And that number can be quite startling if we think about it, because if I look at how much I borrowed in this for my student bills, I started by borrowing $50,000. What I ended up owing is 94, or what I really ended up paying over the entire course of the loan was 94,000. And if I want to know, well, what's the interest? Interest is just total paid minus principal. And if I take the difference between 50,000, so $94,483.20 minus 50,000, that would leave me with $44,483.20 as my interest. And what I have is a quite extreme amount of interest paid back over the course of that loan. So why I think this is all useful is this kind of helps me understand my loan. It helps me, okay, what am I up against? I'm borrowing 50,000, I'm paying back this much, so I'm really I'm kind of just like paying all. It's like the price of borrowing the money. And is this too extreme or not? It's something that we could consider and wonder. But and a lot of times people will get loans without really understanding the scope of it, and that's why I think it's important. And I'm not trying to stress you guys out for those of you who have loans already, but it's just something to be aware of. And for buying a home or buying a car, it's something to know. Like to go back to the point I was making before, can I afford this or not? Well, it really depends. Like with your education is not just a cost, but it's an investment, right? It's an investment in your future so that you can hypothetically get a better job or a higher paying job. Now that's not necessarily guaranteed, but being educated is definitely a very, very strong thing in a lot of businesses, right? Like you can't be a teacher unless you have a degree, right? Or you can't teach a certain level unless you have a particular level of education. So it's like a good type of investment where if you take out a loan for your school balance, uh, also there's different types of debt, and how creditors look at debt is different. Like there's like what's called good debt and bad debt, where like investing in a student loan is often considered good debt, or investing in a house is kind of more is also sort of. But like say for example we're going to buy a really expensive yacht, there's different types of debt where the bank would look at it differently. Like is this investment really benefiting them, or is it just kind of a wasteful expense? But anyways, the math that goes into credit and credit scores and all that is quite complicated, and we're obviously not going to get into that. But um, another thing that I just wanted to mention in principle is that in the world of finance, there's a lot of terms and a lot of random things which a lot of times are designed to really confuse or bewilder the lender, or it's not necessarily always the goal of financial people to confuse you, but a lot of the times people will not really tell you your interest rate, or they won't really. They're not necessarily your best interest or not in their best interest. So say you're going into a car dealership to buy a car, they're often going to want you to finance using their financial plan, which might not be in your best interest because their interest rate might not be very good, or you know like a lot of times they might be able to get you a better price on your car because of the loan that you're getting. But if you were to just pay for the car in cash, they're not going to necessarily give you as good of a deal. So, you know, when, basically be careful when you're dealing with salesmen or people that are trying to get you loans, because they're not necessarily trying to get you a good deal, even though they might claim to be doing that. And that's why it's good to do your homework. It's good to really understand it, and don't sign it unless you're happy with the terms and like you understand the terms. Which is, there's a lot of involvement, but there's definitely a lot of implications to loans, and if we borrow things, like especially with home loans. And like I said before, just because you qualify for a loan, or just because you have a particular max on your credit card, doesn't mean that you can really afford to max out your credit card, or that you can really afford to get a loan. Because let's say I could go to the bank right now and get a $500,000 home loan for myself and my family. Um, does that mean I want to? I mean, it just really depends on me. It's like, is that loan going to be worth it for me, to have all that interest? And I could kind of do the math and see, okay, well, if I get a 30-year loan at a 4% interest rate, what my payment's going to be, how much interest am I going to be spending? And now we have the math at our disposal to kind of look into these things. Also, if you go online and you just look at a calculator, a lot of times websites will do these calculations for you, but I think it's nice to be able to do them on your own to really be able to understand what's happening, as well. But like a lot of people got into a tremendous amount of trouble, I forget when, but 10 to 15 years ago, and there was like the entire economy went through a horrible crash due to lots of people being approved for loans they could not afford. So people all across the United States were getting loans for houses, and a lot of those people, a good portion of those people, ended up defaulting on their loans. And while in general this is not a bad thing for banks, and this is how banks make money, is they make money on the interest that is being paid over the course of the loan, and if it's not paid, they basically get the house back. So it's kind of like they're just gaining money from all these things. But if too many people don't pay off their loans, then the bank is in this huge hole from lending all this money. And if that hole gets too big, which it did, in the late 2000 or in the late 2000s, it can throw off the entire economy. And a lot of people wonder, how did this actually happen? But the gist of it is that a lot of the people who were controlling the loans were getting financial benefits. They were getting bonuses for giving out the loans. So they were pushing through a lot of loans that they shouldn't have been, and there was very poor regulations on loan approval. And so basically, the unethical nature of the managers of those companies, first of all, they caused the entire economy to crash, and they uh, there was a lot of there's a lot of people who were out of their they couldn't afford to pay back their loans. They went through extreme financial crisis. So anyways, this is kind of I'm getting off topic and circling back into the ethics sort of side of things again. But anyways, it's kind of a complex issue, and knowing whether you can afford it, it's sort of just dependent on you. But buying a home, well, you're up for against a tremendous financial barrier for say 20 or 30 years. It at the end of the day, you actually own something. You have property, and you're kind of investing in a way in the in that property, which you could sell later. And a lot of people make a lot of money investing in real estate, um, because they have money. And it's kind of there's another saying in finance, which is you can't make money unless you have money, or the rich stay rich, various sayings like that. But it's like the more money you have, the more money you have to invest, and if you invest wisely, it's going to grow due to the properties of interest. So the thing to remember is you always want to be on the positive side of interest. You want to be gaining money based on interest. You don't want to be spending money on interest. And so it's kind of like being in green versus red. So the goal is to save your money as much as possible. Then once you have some savings, invest that so that you'll be having your money work for you rather than you working for your money. Anyways, that wraps up the lecture on chapter 10. Sorry, I kind of went off the rails there for a little bit, but you should be good to go for the homework and such. And I'll post a little video about the final a little bit later once I know more. But it will include chapter 10, so I recommend working on all the homework, and putting a lot of these formulas into your cheat sheet for the final. Anyways, see y'all. Have a good one.